Thanks. Hey, Mark, thanks for the opportunity today. Uh, just sitting here and listening to all the innovation encapsulated in such a short period of time for presenters today, it's just super exciting to see the collective progress being made across the quantum today. I'm happy to be a small part of it, working at Microsoft on the Azure Quantum team. I spend most of my days driving our logical qubit efforts forward, which I'm going to share a bit more about today. And I'm hopeful just in the few minutes I have is to share with you some of the key efforts we have that all ladder up to a mission to accelerate scientific discovery. So I know that just sounds like some interesting words, but really everything we're doing on a day-to-day basis is directly accruing to this big goal we have. And we think of our work being carved into three separate pillars, if you will, but all, of course, interrelated. The first and foremost, quantum computing. We'll talk a bit about that today. We also are very keen on evolving how applications will take advantage of quantum computers in the not so distant future, and particularly focused on chemistry, material science, and drug discovery for that. We'll talk about some products we have to help that along. And lastly, quantum networking, right? So we have some investments aimed at how to build future interconnects between quantum supercomputers and such, so that all this can come to market in a viable way, targeting commercial advantage in the future. So we try to take a really simplistic view of the quantum computing domain, right? Carving it into three levels. So level one, foundational. This is what everyone's really familiar with today. Physical qubits. Yes, you can prove out quantum advantage with some physical qubits, but it's on very contrived problems. I think a common thread I've heard from everybody today is this push towards level two or resilient or reliable quantum computing, right? And this is the advent of logical qubits, right? Where you really start to scratch at scientific advantage for certain problems around 100 logical qubits, and lots of work going on in this space. And we'll go into some more depth in a second on that from our perspective. And then finally, everyone's driving toward this idea of scale, right? Where you can realize a true quantum supercomputer, get after commercial advantage. And that's something that we see interchangeable with fault-tolerant quantum computing or utility computing. So very much aligned with everybody else today in that regard. So looking specifically about this transition from level one to level two, we're really, really proud of some recent co-innovation we've done with a longtime partner, Quantinuum. They're an ion trap quantum endpoint, known for their very high fidelity ion trap qubits. So recently we were really excited about working together, combining Microsoft's qubit virtualization system on top of those high fidelity ion trap qubits to build what we believe to be the most reliable logical qubits on record today. And we demonstrated and published the ability to show up to 800x improvement in error rate when comparing logical to physical for the same circuit operations, right? So definitely stepping into that realm of reliability with those results. And for those that are deeper on the error correction side, we were also to demonstrate multiple successful rounds of syndrome extraction, right, without disrupting that circuit. So that is truly a foundational element on that path to fault-tolerant quantum computing. So we're really excited about that result. And then what are we going to do with this progress, right? So I mentioned chemistry and material science at the start. Our CEO, Satya, is really good at coming up with very concise statements that represent big missions for the company. And I love this one. Our goal is to compress the next 250 years of chemistry into the next 25, right? Harnessing all these great advancements. So how do we plan to do that? We have a really cool product called Azure Quantum Elements. The idea, a lot of depth here, we'll just gloss over it for now, but the idea is combining high performance compute to the scale that affords, the speed through AI, and the accuracy of quantum endpoints, right? So customers can bring on their computational chemistry workflows to this platform today. And then as that quantum endpoint continues to advance, they can use that to increase the accuracy more and more for chemistry simulations and whatnot to accelerate scientific discovery. So if you're keen to learn more about Azure Quantum Elements, hit that QR code. I'll copy the link over in chat as we go today. And also, if you're interested in learning what's under the hood for that recent reliable quantum computing demonstration with our partner Quantinuum, there's some more information as that provided there as well. So thank you.